Have you ever used a shopping app that perfectly recommends what you want? Or played a game that reacts instantly to every move? How does these apps make the decisions or repeat the tasks so effortlessly? Well, today we are going to crack the code behind this everyday task with the Python control structure. Buckle up, because by the end of this video, you will have the tools to write a smart, more efficient code. Welcome future data scientist, I am Amarnath, and today we are dive into the heart of Python programming called control structure. These are the directors of your code. Decide which part of your program to center the stage and when. Together, we'll master them to make your program not just work smartly. There are three primary types of control structure in the Python: sequential control, selection control, and iterative control. First, let's talk about sequential control. Think of it as a train moving along its tracks, stopping at each station in order. In Python, this means executing each line of code one after the other, exactly as you written in them. Let's check some example on this. First, we will write the three print statement to demonstrate how sequential control statements works. To understand the flow of execution, we'll place the breakpoint and run the code in debugging mode. As the execution begins, it will first hit the first line. Allow us to move to the next step. The first line will print the hello, and the next execution moves to the second line. After printing the welcome, it will proceed to the third line where it prints the welcome to tutorials. Since there is no code after the third line, the execution will exit. Here, each print statement runs in the order it's written, just like our train stops at each station. Simple, right? But what if you want our train to choose the different tracks or repeat this section of its journey? That's where selection and iteration controls comes in. Next up is selection control, where decisions are made. Imagine you are driving and reach to fork in the road. Depending on the conditions, you will choose the one path or the other. In Python, this is done using if statement. To demonstrate the if-else condition, we will take the input from the user and check whether the given number is greater than or 10. First, we will declare the variable to store the number entered by the user. Using an if statement, we will check if the number is greater than 10. If it is, we will print the message, or else we will use the else statement to print the different message. Here now we will execute this code. First it will ask for the entering the input value. After it will check whether the given value is less than or 10. It is less than 10 and it will go directly to the print statement. The value is less than 10. So it will print the value is less than 10. Now again we will check. It will check whether the value is less than 10 or not. Now it is 15. Then it will go to the else statement and it will print the value is greater than 10. Simple. Here, the program checks if the input value is less than 10. If it is, it takes one path. If not, it takes another path. This is the essence of selection control, making a choice based on the conditions. Finally, we have iterative control, which is all about repetition. Think of it like running a laps around a tracks. Each laps bring you closer to your goal. In Python, we use the loops to repeat the task until the condition is met. To demonstrate a loop, we'll use a while loop. First, we'll declare the variable to serve as the loop counter. While the condition checks if the variable is less than 10 and will print the variables and will increment by 1. So we'll execute this code. So initially the variable will be 0 and it will check the condition whether the variable is less than 10. So it is 0, chose print variable. It will print the 0, then it will increment the variable by 1. Now the variable value is 1, so it will print the variable 1. The loop will continue as long as the variable is less than 10. When the variable reached 10, the condition fails and the loop exists. Here, the loop keeps printing the value of var and increase it by 1 until var is no longer than 10. This repetitive action is what we call looping. Now that we have covered the basics, let's dive deeper into the conditional statements. We will explore the if else, else if and even nested if statements. Think of this as a decision tree, helping you navigate complex choices in your code. If statement. An if statement is like saying, if it is raining, take an umbrella. In this example, if the number is greater than 0, then the program prints the number is positive. It's a simple but powerful way to control the flow of your program. Here, first we will demonstrate a simple if statement. First we will declare the variable, that is variable num, and we will assign it as a 5. And in if condition, number is greater than 0, then it will print is positive. First, we will assign the number is equal to 5. In the next condition, if condition, then it will check number is greater than 0 or not. If it is 0, then it will print the number is positive. Here, if number is greater than 0, it prints number is positive. Simple and effective. If else statement. Sometimes, if we need alternative action, if the condition isn't met, that's where if else statement comes in. It's like saying, if it is raining, take an umbrella, else wear sunglasses. Now we will demonstrate simple if else statement. Now the user will enter his score, and based on the score we will tell whether the student is passed or not. So first we will store the score in a variable called score. Then based on this score, we will check whether the score is greater than or equal to 50 or not. If it is greater than or equal to 50, we will print as a pass, or else it will be fail. You can use the bracket, or else you can use without bracket also. We'll run. So first it will ask for the enter the score of the user. So here we'll type 75. Now it will check whether the score is greater than 50 or not. Now it is greater than or greater than 50, so it will print as a pass. Pass. Now again we will check. Again we'll enter less than 50, that is 35. Again it will check whether it is greater than or 50. Now it is 35, means less than 50, so it will print as a fail. Here, if the score is 50 or higher, it prints pass. Otherwise, it prints fail. These structures allow for clear decision making. What if we have a multiple conditions? Enter elif statement. They allow for multiple checks in sequence, like saying, if it is raining, take an umbrella. If it is sunny, wear a sunglasses. If it is cloudy, take a light jacket. First, we will get the score of the user. And based on the score, we will print as a grade A, grade B, grade C and grade D. If the score is greater than 90, we will print as a grade A. And if the score is greater than 75 and less than 90, then we will print as a grade B. And the score is greater than 60 and less than 75, then we will print as a grade C. And if the score is less than 60, then we will print as a grade D. Let's see how can we demonstrate this logic. First, we will get the score of the user. Based on the score, we will check whether the score is greater than 90, 75, 60 or less than 60. Score greater than or equal to 90. We'll run this code. Now we will enter the score. Suppose 80. Then it will check whether the score is greater than or equal to 90. Since it is not, it will go to else if, and it will check whether the score is greater than 75. And it will check it is greater than 75. Then it will print grade B. Now again we will check one more example. Now again we will check one more example. Suppose now it will ask to enter the score. Now we will give less than 60, that is 50. So now it will check whether the score is greater than or equal to 90. Since it is not there, it will go to else if, and again it will check whether the score is greater than 75 or not. If it is not, so it will go again next else if, and it will check whether the score is greater than 60. Since it is not, again it will go. Now it will go to the else, and it will print the final print statement. Here, the programs check several range for score and assign the grade accordingly. This allows for more nuanced decision making. Nested if statement allow you to add a layers of decision making. It's like saying, if it is raining, take an umbrella. If it is also a windy, wear a raincoat. To demonstrate nested if statement, first we will get the number from the user, and we will check whether number is positive or negative. If it is positive, we will check whether number is odd or even. If it is even, we will print positive and even number, and if it is an odd number, then we will print positive and odd number. If the user provides the negative number, then we will print negative number. Let's check on that. First we will take the number from the user. If num is greater than 0, then if num mod 2 is equal to 0, then print positive and even number. Else print and odd number. Else print negative number. So first we will check one by one. We'll put the breakpoint and run it. First it will check. It will enter to first line. It will ask for the number. Enter the number 50, and since it is a greater than 0, it will be true, and it will check whether it is even. Since it is a even, positive and even number. We'll check means it is negative number. In this example, the program first checks if num is positive. If it is, it then checks if number is even or odd. Nested condition let you handle detailed multi-layered decision in your program. Now let's talk loops. Loops let you repeat a block of code multiple times, just like cursor that keeps spinning. We'll cover for loop, while loops, and how to control them with break and continue statements. For loops. A for loop is like counting items in the list. It repeats the block of code a fixed number of times. Let's see in action. To demonstrate the for loop, we will create the fruits list which contains apple, banana, cherry, etc. We will iterate over the fruits and will print each values in the fruits. So first we will create the fruits list. Then we will create the for loop for fruit in fruits. So it will get the each value in the fruits and assign to fruit, and we will print this value in the for loop. So when we execute this, first it will create the fruits list. This is the fruit list: apple, orange, banana and cherry. So then in the for loop, each values of the fruits will be assigned to fruit, and then it will be passed to the print statement. So we will check one by one step. First it will assign the apple. Again it will go back. And now orange, banana, cherry. So cherry is the last, so it exits the for loop. This loop prints each fruits in the list. For loops are the perfect for iteration over the collections. And if you want to control the number of iteration, you can use the range function. The range function generates a sequence of numbers useful for loops. It's like setting a starting point, ending point, and step size. To demonstrate the range function, we will use the range function in the for loop. That is, for I in range 1, 11, 2. So we'll print I. So here the range index start from 0 and ends at n-1. That is, here it start from 1 and n-1 is 11 minus 1, that is 10, and it increments by 2 steps. That is, it ignore the 0 and start printing 1, 3, 5, 7, 9. So we will execute this code. So first it will initiate. Here first value is 1. As I told, it will ignore the 0. It go to the second step, that is 1. Prints the 1 and it ignores the 2. And now 2 is ignored and the I value will be the 3 and the 3 is assigned to I, then same will be printed. So the loops will keeps on continue till the now I is 9. N minus 1 is 10. So if 9 after 10 will appear, but here the step size is 2, so the 10 is ignored, and so the for loop is ignored. This loop prints from 1 to 10. The range function is versatile, allow you to create customized sequence. Nested for loops allow you to handle more complex data structure. Let's create a simple multiplication table as an example. We will demonstrate the nested for loop by creating a multiplication table from 1 to 10. In this example, we will use two for loops to generate the multiplication table. The first for loop will iterate through numbers 1 to 10, and the second loop will generate the multiplication table from each of these numbers. Let's check that. For I in range 1, 11, this loop iterates I over the numbers from 1 to 10. Each value for I represents the current rows of the multiplication table. For each value of I, nothing but each rows, the inner loop iterates j over the numbers from 1 to 10. Each value of j represents the current column in the row. Next I, j. Here, inside the inner loop, the code multiplies the current value of I and j. This product is the results of you see in the multiplication table. Printing I, j. The printing I, j statement outputs the product of I and j on the same line and separated by the space that is mentioned in the end. After inner loop completes, the print statement moves the cursor to the next line. This ensures that each row of the multiplication table starts on the new line. So let's run this code. You can see here that this is the multiplication table from 1 to 10. Each row corresponds to the multiplication number I by the each number j in the loop. This script generates the multiplication table. Nested loops are powerful for handling the tasks that involves multiple layers of iteration. While loops. A while loops repeats as long as condition is true, like running until you reach the finish line. Let's see an example. We will demonstrate the while loop. First, we will initiate the count. Count is equal to 0. The variable count is initialized to 0. This variable will be used to control the loop. Next, the while condition. This while loop checks if the condition count less than 5 is true. If the condition is true, the loop body will execute it. As long as the count is less than 5, the loop will continue to run. Next, the body of the while loop. Inside the loop, the current value of count is printed to console. This shows the progress of the loop as it counts from 0 to 4. Next, after printing the value of count. The statement count plus is equal to 1 increases the value of the count by 1. This is the short form of our count is equal to count plus 1. This increment ensures that the count eventually reach 5, which will make the loop condition count less than 5 is false and stop the loop. When we run the code, this output shows the value of count as it increments from 0 to 4 before the loop exits. Here, loop prints the number from 0 to 4. While loops are greater when you don't know the advance how many times you need to repeat the task. Break and continue statement. Finally, let's explore the break and continue statements. These control loop execution like hitting the break or skipping the steps. Now, we demonstrate the break statement. We will use the break statement and inside the for loop condition. Let's check out how it is. And if I is equal to break. The loop iterates over the number from 1 to 10. The range 1, 11 generates the sequence of numbers starting at 1 and ending at 10. The variable I takes each value from this range in each iteration of the loop. Inside the loop, there is an if statement that checks whether the I is equal to 5. If I is 5, the condition is true, and the code inside if block is executed. The break statement is used to immediately exit the loop, regardless where the loop is in the execution. When I equal to 5, the break statement is executed, which stops the loop entirely, so no further iteration occurs. If I is not equal to 5, the loop continues, and the current value of I is printed into console. This loop will print each value of I until reach 5. At which point it will break out of the loop. Now we will execute this script. This output shows the loop's prints number from 1 to 4. Once the loop reaches 5, the breaks out the stop execution, so the number 5 through 10 are never printed. In this loop, break stop the loops when I equal to 5. It's useful for exiting a loop early. This is the code snippet for the example of the continue statement. Let's break it out how it works. The loop iterates over number from 1 to 10. The range 1, 11 generates the sequence of numbers starting at 1 and ending at 10. The variable I takes each value from the range in each iteration for the loop. Next, the if condition. Here, the mod operation is used to find the remainder when I is divided by 2. If the remainder is 0, it means I is an even number. If I is even, then the continue statement is executed. The continue statement tells the loop to skip the rest of the code inside the loop for the current iteration and move to the next iteration. As a result, the print I statement is not executed for the even numbers. If I is not even, the continue statement is bypasses and the current value of I is printed on the console. This means only odd number of I from 1 to 10 will be printed. Now we will execute this code. The loop iterates over the number from 1 to 10. For each number, it checks whether the number is even using the mod operation. If number is even, then the continue statement is executed, which skips the printing the step for the iteration. As a result, only odd number is printed. It's handy when you want to skip the certain condition but keeps looping. Now let's combine what you have learned. We'll create a program that identifies the prime number within the range. This code snippet is designed to find and print all prime number between 2 to 20. Let's break it out. The loop iterates over from 2 to 20. The range 2, 21 generates the sequence of number starting at 2 and ending at 20. The variable num takes each value from this range in each iteration of the loop, representing the current number to be checked for the primality. At start of each iteration, we assume that the current number num is a prime number by setting is prime is to true. This assumption will be tested in the inner loop. This loop checks whether num is divisible by any number in I in the range from 2 to num minus 1. The variable I takes each value from this range in each iteration, representing a potential divisor of num. In this condition, the mod operation used to check if num is divisible by I. If num is divisible by any I, it means num is not a prime number. If the condition num mod I is equal to 0 is true, it means that num is divisor other than 1 and itself, so it is not a prime. We set is prime to false to indicates that num is not a prime number, and use the break to exit the inner loop since we don't need to check further. After the inner loop completes, we check whether the is prime is still true or not. If is prime is true, it means that no divisor we have found and num is a prime number. If num is confirmed to be prime, it's printed on the console. The outer loop iterates through each numbers in the specific range, assuming initially that each number is a prime. The inner loop checks for divisibility by any number between 2 to number itself. If the divisor is found, the number is marked as a non-prime and the loop exits early. If no divisors are found, the number is confirmed as a prime and printed. This script checks each number from 2 to 20, identify the primes, it combines the nested loops, conditions and break statements, showcasing that power of control structure. Combining conditions and loops can solve complex problems. Example, user login simulation. We simulate the multiple logins attempts. This variable sets the maximum number of times the user can try to enter the password before access is denied. Now, correct password is equal to password 123. This is the password that user must enter correctly to log in. If the user enters the same correct password, then it will allow us to log into the application. This variable counts keep track on how many times the user has tried to enter the password. This loop controls the number of times the user can attempt to enter the correct password. Inside the loop, the program asks the user to input their password. The enter password is stored in the password variable. The program checks if the enter password matches to the correct password. If the password is correct, the program prints login successfully. The loop is terminated using the break because the correct password has been entered. else if the password is incorrect, the else block is executed, the attempts count is incremented by 1. The user is notified that password is incorrect and told how many attempts they have been left. If attempts is equal to max attempts, print many attempts access denied. After the loop, the program checks if the user has used up all their attempts. If the number of attempts is equal to maximum attempts, it means that user has tried the maximum number of times without success. The program prints too many attempts and access denied, and the user is logged out. Let's check this. Enter the password. Say I will use password. Yeah. 1 2 3 4 3 4 5 6 x 0 access denied. The code uses a while loop to manage the number of attempts and checks the entered password against a predefined correct password. If the correct password is entered, access is granted. Otherwise, after 3 failed attempts, access is denied. This script limits the login attempts and handles success or failure. Next example is simple fun number guessing game. Here, user keep guessing until they find the correct number. In this code example, this is a guessing game where the user has to guess a randomly generated number between 1 and 10. First, we will import the random. The code begins by importing the Python built-in module that is random, which allows us to generate the random numbers. Next, number to guess. The randint 1,10 function generates the random integer between 1 and 10 inclusive. This number is stored in the variable number to guess, and the user will need to guess this number. Next, guess is equal to 0. The variable guess is initialized to 0 as a placeholder. This variable will hold the user guesses. Guess not equal to number to guess, then guess input guess the number variable guess is initialized to 0 as a placeholder. This variable holds the user guesses. Then the loop will continue to execute as long as user guess is not equal to the number to guess. This ensures that user keeps guessing until they correctly identify the number. The user is prompted to guess the number by entering the value between 1 and 10. The input function reads the user input and converts it into integer and assigns to the guess variable. If guess less than number to guess, print here. Else if guess greater than number to guess, print lower. Print congratulations, you have guessed it. If the user guess is lower than the random number, the program prints higher, indicates that the correct number is higher than their guess. And if the user guess is higher than the random number, the program prints lower, indicates that the correct number is lower than their guess. Once the user's guess is correct, the loop exits and the program prints, "Congratulations, your guess is correct," and acknowledging that they guessed. The program gives the user to feedback on whether their guess should be higher or the lower until they correctly guess the number. It uses a while loop to continue the guessing process and ends with a congratulations message with the correct number is guessed. This code illustrates the basic concepts like loops, conditions, and user input in the Python, all while creating the interactive and fun guessing game. Best practice. To write the efficient code, follow this best practice. Write clean and readable code. Use descriptive variable names and keep your code blocks shorter and focused. And commit your code to explain the complex logic. Avoid common pitfall. Be mindful of infinite loops. This is the major concern will appear if you not handle the loops correctly. Debugging tips. Use print statement to track the variables values and utilize the debugging tools and breakpoints to debug your code. Let's recap what we have learned today. We have covered sequential control, selection control, and iterative control. These control structures are foundation for any program you will write in the Python. Remember, sequential control is your basic train tracker. Selection control helps your code make decisions. And iterative control allows you to code the repetitive task until it reaches the goal. Now that you have got the basic down, it's time to practice. Try writing some code using these control structure and share your result in the comment below. If you enjoyed this video, give the thumbs up and don't forget to subscribe for more Python tricks and tips. See you next video. Bye bye.